When a consumer decides how much to consume and how much to save, they consider both the present and the future. The more he or she will consume today, the less he or she will be able to consume tomorrow. The economist Irving Fisher developed the model with which economists analyze how rational, forward looking consumers make intertemporal choices, that is, choices involving different periods of time. The concept will be clear if we understand the theory with this problem. Please read the problem properly. Here it is asked that a consumer with two period horizon has utility function u equals to c1 into c2, and the actual income is y1 equals to 10,000 and expected income is y2 is equals to 5,250. That means consumer has two time period 1 and period 2. Period 1 means present and period 2 means future. The consumption in period 1 is C1 and the consumption expenditure in period 2 is C2. The income in period 1 is Y1, that is equals to 10,000, and the income in period 2, that is expected income in period 2, is Y2, that is equals to 5,250, and the rate of interest is 5%. What will be the optimal consumption expenditure? Let's start to solve the problem. Suppose the consumer divides its lifetime into two periods, period 1 and period 2. Period 1 is present and period 2 is future. In period 1, he consumes C1 and in period 2, he consumes C2. That is, his consumption expenditure is expected to be C2 in the future. In period 1, his income is 10,000, y1 equals to 10,000, and in period 2, his income is y2 equals to 5,250, and the prevailing rate of interest is said to be 5%. Now, his period 1 consumption expenditure will be C1 equals to Y1 minus S. Here S is the saving of the consumer. The implication of this equation is that consumer is saving in period 1 and rest is consumed. That is C1 equals to Y1 minus saving. Consumer is saving, that means he is thinking about his future consumption that I told in the beginning of the video. So the future consumption, that is period 2 consumption, will be C2 equals to Y2 plus S plus 5 by 100 into S. So what is the implication of S plus 5 by 100 into S? It is the income of the consumer from saving in period 1. We know that rate of interest for saving is 5%. So S is the saving and 5 by 100 into S is the interest. So total earning from the saving is S plus 5 by 100 into S. So from this equation we can get S equals to 100 C2 divided by 105 minus 100 Y2 divided by 105. Please see the deduction. Now putting the value of S in the first equation, C1 equals to Y1 minus S. In this equation, putting the value of S, we can get another equation, and this is nothing but the intertemporal budget constraint of the consumer. This is the equation that relates consumption in the two periods to the income of the two periods. How the consumptions in the two periods are related to the income of the two periods are shown in this equation. Now the utility function is given by u equals to C1 into C2. This is the utility function of the consumer. So the problem before the consumer is to maximize utility function, that is utility, subject to the budget constraint, intertemporal budget constraint. To maximize utility subject to the intertemporal budget constraint. That is how much consumption expenditure in period 1 and how much consumption expenditure in period 2 the consumer should choose to maximize his utility subject to the budget constraint. Here we already know the value of y1 and y2, so put the value in its place. We can get a simplified equation, that is C1 plus 100 C2 divided by 105 equals to 15,000. See on the screen. So the Lagrange function to calculate the optimal consumption expenditure in both the period, the Lagrange function will be L equals to C1 into C2 plus lambda, that is Lagrange multiplier, into 15,000 minus C1 minus 100 C2 by 105. So the FOC, that is first order condition of the constraint optimization, will be del L del C1 equals to 0, del L del C2 equals to 0, and del L del lambda equals to 0. So from equation 1 and 2, 1 equation 1 and equation 2 are del L del C1, that is partial derivative of L with respect to C1 and partial derivative of L with respect to C2. From these two equations, equating these two equations, we can get lambda equals to C2 equals to 105 C1 divided by 100. So solving this equation, we can get a relation between C1 and C2, that is C1 equals to 100 C2 divided by 105. So putting this value of C1 in equation 3 is the del L del lambda, that is partial derivative of L with respect to lambda. Putting the value of C1 in that equation, we get, you can see on the screen, in the place of C1 we are putting the value C1 equals to 100 C2 divided by 105, and from there solving this equation we can get the value of C2. So C2, that is the consumption expenditure in period 2, is 7,875. Now C1 equals to, from this relation between C1 and C2, putting the value of C2 in its place, we can get the value of C1. So the value of C1 will be 7,500. That is consumption expenditure in period 1 will be 7,500. So the implication is that subject to the intertemporal budget constraint, the consumer's lifetime utility will be maximized if he chooses to consume 7,500 in the present period and 7,875 in the future.